Hey everyone, this is SATdecoded.com. I want to continue our conversation about graph functions from the earlier video, but let's talk about a more advanced concept relating to graph functions called intersecting graph functions. Intersecting graph function questions involve usually two, sometimes even more, graphs. You see like there's a graph right here and another graph right here that actually intersect at some point, for example, at this point right here. And then they'll ask you some sort of question about it. So let's take a look at question 1 right here. It says, if g of b equals c of b, what is b? And these are the possible choices for b. So if g of b equals c of b, we know that g of b is a function, and we know that c of b is also a function, and this function equals this function. Well, functions are outputs. So what we really have is a case of output equals another output. They're the same output. And if you remember what that means, we know that outputs are y values, so what we really have is a y equals y situation. And the question is asking, what is b? Well, b is inside the parentheses for both of them. So that means for both functions, both for the g function as well as the c function, the value of b is inside the parentheses, so those are inputs. B is the input. So in other words, b is an x value. So it's b is an input. So we want to find out which input is correct. Since these are all representing possible b values, these are all possible input values. So if we take a look at this y equals y, we can understand that for both functions, the y is going to be the same. So the point of intersection right here, it looks like it's 4, 3 as the ordered pair. It looks like that point of intersection shows us the place where the y values are exactly the same. For the function c, which is this straight line right here, when the y value is 3, the y value for the function g is also 3. So when they both have the same y value, we satisfy this condition. G of b equals c of b. Y equals y. 3 equals 3. So when 3 equals 3, what is the corresponding x value? In other words, what is the corresponding input value? It happens to be 4. So therefore, we've just figured out that x equals 4. And since we know that the x equals our b, we know that b equals 4. So that's our answer. What if they asked us, what is g of b? And in this case, they don't give us any multiple choice answers. It's just a gridding question, so we have to truly figure this out all on our own. So g of b, that's a whole function. So really what they're asking for is, what is the y value, or what is the output value? Well, we found out earlier that b was equal to 4. So if that is our input, let's take a look at the x-axis, because the x-axis is our input axis. So here's 4, and it goes up to the point of intersection again, so it doesn't even really matter which graph we're looking at, but since they're asking about the g of b, let's just focus on the g function right here. Really, we're just focusing on this point right here. So when the b is 4, the y is 3. So therefore, the y equals 3. And that is our final answer. Let's take a look at another similar question to this. So I'm going to go ahead and clear this and open up another question. So here it is. It says, if f of a equals g of a, what could a be? Notice how this time there are no tick marks on the graph at all. And that's actually not a mistake. That's done on purpose. This really requires us to reason our way through this question. So if f of a equals g of a, again, that means the y equals the y, because f of a by itself is an output, and outputs are y's. G of a as a whole function is also an output, which is also y. So we have output equals output, or y equals y. So we want to find the point where y does equal y for both the f function as well as the g function. So this straight line right here is the g function, g of x, and this curvy line is the f function, f of x. So their point of intersection is right here. The point of intersection is always the spot where the output will equal the output, the y will equal the y. I have no idea what this y point is, but it really doesn't matter because the question is not asking for a y value. They're asking what could a be. And a, if you notice, is inside the parentheses for both functions. So that makes a an input because remember, inputs are inside the parentheses. So we're really just looking for an x value. These are possible a's, and a's equal x, which equal input. So right here is the point of intersection when y equals y, when output equals output. So let's look at the corresponding input. It's going to be whatever this is down here. Since there's no tick marks, I can't be sure exactly what that is. But here's where looking at the answers can help us out. We have -2, 0, 1, 2, and 5. Notice how all of these right here are on the wrong portion of the graph. 0, if x is 0, that's going to be right here. Here might be 1, here might be 2, and here might be 5. The only one that is negative, because it's on this side of the graph, is -2. So that's our only possible choice. We need something negative because it's on the left side of the y-axis, which represents negative stuff. So that's our answer. Alright guys, good luck, and I'll see you in the next video.